Shake Table Tower by Sharon Song and Ali Shipke. We started by sketching out what we wanted our building to look like. We changed our plans and made 4 triangles on the walls instead of 3. We also had a building code saying that each floor of the building had to be 18 centimeters tall, making the total height of our tower 36 centimeters. The first step of building our tower was making the foundation, pillars, and the floors. We angled the posts a little bit inwards because the tower will be more sturdy this way. For the next step, we added straws that crisscrossed on the walls and the floor to make 4 triangles on each side. We changed the plan from a diagram because we realized that if we did not cross the straws, that would only make 3 triangles, and if we did cross them, that would be 4 triangles. More triangles means that the tower is stronger, which we want. For the third step, we put on construction paper and beam supports for the floors. We put on the construction paper first, then we put the beams going from the foundation to the first floor and the first floor to the second floor. We put the beams in the middle of the stories so the weight is balanced out between the floors. The final step, we had to add a roof. Allie and I decided to make a staircase-shaped roof with a flag at the top that says number 1. We then put construction paper on all sides of the stairs and the walls, except for one side, for we needed to put the sandbags on the floor. The construction sketch shows the dimensions of the building. Each floor is 18 centimeters apart, but the roof was 28 centimeters high. The width from the foundation to the second floor was getting bigger to smaller so that the building would be more stable and that we could use less straws. Allie and I tested our building with 4 sandbags in all, each weighing 100 grams. Later, we put 4 more sandbags in the tower, 2 on each floor, and the tower stood up nice and strong. On the walls and the floors, we crisscrossed the straws to strengthen the building. We did this because crisscross straws form triangles, which is the strongest shape. Also, we put beams inside the building so it supports the weight on the floor above it. The strongest parts of our building are probably the corners. I think that because that is where most of the straws meet and there's a lot of tape in the corner of our building. The weakest part of our building is probably the first floor beams. Allie and I think this because when we look back at our slow-mo video, this is where our tower collapsed. My partner and I put most of the tape at the corners of our building. We did this because we had to tape the straws onto the beams, which gets very thick if you put a lot of tape. Putting tape in the middle of the 2 straws is probably where we put the least amount of tape because the tape in the middle of the pair is just meant to keep the 2 straws together. The construction paper went on top of the straws to make a floor. This is not meant to hold up the weights, but so that the sandbags don't fall through the empty gaps of the straws. Mr. Closet is now testing our tower with a major earthquake. There are 10 sandbags on the tower, which means our tower is withstanding 1,000 grams. No! No!
Oh, it's wiggling.
5, 4, 3, 2,
1. Happy birthday!
There are 16 sandbags on our tower when the building collapses. Therefore, our tower successfully held 14 sandbags.
Begin!
it's a straw! On this graph, it shows the movement of our tower. The blue line, which is the z-axis, shows the movement of up and down. The orange line, y-axis, shows back to front. And lastly, the blue line, x-axis, shows the side-to-side movement. Hello, this is Science News with Sharon Song. Our tower supported 14 sandbags, and at the 16th sandbag, our tower collapsed. Our tower collapsed at the beams right here because we looked back at our slow-mo video and we saw that it cracked right here in the first 4 beams. We probably would make the tower stronger by adding another beam across the walls. We would probably do this because triangles are the strongest shape, and the more triangles the better. I learned that, as I said before, triangles are very strong, and also that crossing straws or beams or whatever material you're using is a very good idea. And also, the beams in the middle of our tower, where my finger is, that is very helpful too, to hold up the floors above. I really liked building our tower because it was a hands-on building, and I really loved being with a partner.
Hello, this is Ali Shivka from Science News. Our tower successfully held 14 sandbags. It collapsed on the 16th. Our building failed at the first floor beams. We looked back at the slow-mo video and realized that only 2 straws right here is not enough. We could have made our tower stronger by adding another straw down the middle right here, because though these are very strong, they could have been stronger. The more triangles the better, because triangles are one of the strongest shapes. Something that I learned about building an earthquake-proof tower is that triangles, beams, and crossing straws are very important because, as I said before, triangles are the strongest shape. Something that I liked about the lab was interacting with my partner and actually being able to be creative with your tower and building an earthquake-proof tower.